Hello, Mr. Barry's Geometry. I am looking at this homework or this assignment. I'm not sure exactly when you're doing it, but for those of you online, getting this turned in, or if you're missing today, or if you missed this assignment, whatever the reason being, this assignment, I have every other one done for you. We are going to be working with, and I'm sure you know this from class, trigonomic ratios, and one phrase or little acronyms that we're going to use to remind us how to solve these are SO, CA, and TOA, standing for when we need to use the sine function on our calculator. We have sine, cosine, tangent, so CA, TOA. The OH stands for opposite and hypotenuse. When we're working with cosine, we're working with the adjacent and the hypotenuse. And tangent, we're working with opposite and adjacent. How do we know what's opposite, what's adjacent, what's hypotenuse? Well, the hypotenuse is always going to be the side of the triangle that's across from the 90 degrees. So this is the hypotenuse, this is the hypotenuse, and another example, this is the hypotenuse. Now, whether it's adjacent or opposite, that depends on your perspective, what you are looking at. Okay, so let's get started, and I think that will help you understand the adjacent and opposite a little bit better. So we got to write sine for m, cosine for m, and tangent for m. So I'm looking at m and number 11. So sine for m, so we're thinking of so opposite over hypotenuse. So for m, the opposite over the hypotenuse is going to be 7 over 25. So your sine for m is going to be 7 over 25 for number 11. Your cosine for m is the adjacent over the hypotenuse. Now, the adjacent to m has got to be 24 because 25 is the hypotenuse. You know, you always have that hypotenuse. You know where the hypotenuse always is, across from the 90-degree angle. So we have the adjacent 24 over 25. So 24 goes over 25. Okay, so that's CA. And then the tangent of m, so we go to TOA. The tangent of m is going to be equal to opposite over adjacent. So the opposite over the adjacent. I picked the adjacent, not the hypotenuse. So the opposite over the adjacent. Adjacent means next to, so the side next to. But I know we have two of them next to it, but remember this one's the hypotenuse. So it's going to be 7 over 24 for TOA, for tangent. So the tangent of m equals 7 over 24. Now I'm not going to explain each one that way, or else this would be an hour-long video, so here we go. 13. The sine of m is going to be the opposite over the hypotenuse. So 2 and the square root of 3 over 4. So 2 square root of 3 over 4. The cosine is going to be the adjacent over the hypotenuse. So 2 over 4. Cosine 2 over 4. And then the tangent is going to be the opposite over the adjacent, 2 and square root of 3 over 2. 2 square root of 3 over 2. Just getting those ratios down. Now we're going to actually start working with them. And I do the even ones because I wanted to show you more. If I just showed you odd, I would only get 3. If I showed you even, I would get 4, and I shot for 4. So here we go. I switch over to the evens. Now, we are going to just solve for x. So I know this angle 35, and I have the opposite that I need to figure out, and I know the hypotenuse. So opposite hypotenuse, OH, I'm going to go with sine. So the sine of 35 is going to equal x over 20. Sine of 35 equals x over 20. What I do is I just multiply both sides by 20. So take the sine of 35 on your calculator, and how you're going to do that, you're just going to press sine 35, wrap it in parentheses, it'll start you off that way, and times 20. Because I'm getting the x by itself, because this is divided by 20, I do the opposite of that. Hit equals, That gives you the answer, 11.5, rounding to the nearest tenth, it said. So 11.5. Okay, 16. I'm going to, I have 64, I know that, so I have opposite and adjacent. Opposite and adjacent is TOA. So I'm going to take the tangent of 64. So tangent of 64 is equal to x over 7. Okay, and so I multiply both sides by 7, and I get 14.3. When I take the tangent of 64 times 7. You, once again, using the tangent button, using the correct buttons on your calculator. 17. 17 is a little bit different because we got to do a little extra operation here. So I have 36 degrees, and I know the opposite, and here's the hypotenuse. So opposite over hypotenuse. Opposite over hypotenuse is sine. So I take the sine of 36 equals 10 over x. Now, here's the thing. I multiply both, remember this was divided by 20, so I multiply both sides by 20. Well, this is multiplied by, or this is divided by x, so I multiply both sides by x. That moves, this x over here, and I get rid of the x over here. Now I got to take 10 divided by the sine, I got to divide both sides by sine 36. 10 divided by the sine of 36 gives me 17. It's 17.001 or something like that. 19, we are looking for x, so, and I know this 25, so I have opposite over adjacent, that's TOA. So that's tangent of 25 equals the opposite 10 over x. So I multiply both sides by x, and then I divide both sides by the tangent, so 10 divided by tangent of 25 gives you about 21.4. Now, I took on number 21. I switched back to the odds. Go ahead and try the ones that I don't do on your own. You become, if you make mistakes and correct them, you're growing anyways, so try them out. An escalator in the subway station has a vertical rise of 195 feet and 9.5 inches, and the rise at the angle of 10.4 degrees. How long is the escalator? Round to the nearest foot. Well, I changed 195 feet and 9.5 inches to just feet. So 9.5 inches ends up being 0.79 of a foot. I just took 9.5 divided by 12. So I got it just in feet. That makes it a little bit nicer. And I drew a little thing here, imagining that this is 10.4, so I could figure out that I needed sine because I know the opposite and hypotenuse. So OH, SOH. So sine of 10.4 equals that 195, the opposite over the hypotenuse. So I multiply both sides by x, and then I divide both sides by the 10.4, and you get a 1,084.6 foot escalator. Hopefully this helps, and like I said, try the other ones on your own, and just remember SOHCAHTOA. That will help.